But we're going to go ahead and get started today. I think a few more people might trickle in as we go. Today's going to be a little bit different than our sort of standard webinar setup of the past couple of webinars we've done. Instead of doing maybe some presentations on specific topics or terminology or things like that, we have two amazing scientists here who are going to give us a little bit of background into what they do for work and how they sort of got there, and maybe how science policy plays or doesn't play a role in their current positions. So we have Dr. Emily Osborne, who is a current research scientist with the Ocean Chemistry and Ecosystem Division in NOAA's Atlantic Oceanographic and Meteorological Laboratory. That is a mouthful. And Dr. Russell Callender, who is also a Texas A&M alum, who's the director of Washington Sea Grant in the College of Environment at the University of Washington as well. So without further ado, I'll sort of let them give their backgrounds, and then we'll open it up to questions or Q&As for anyone that has any interest.
Awesome. Thanks so much, Tacey. And thank you for the invitation and for organizing, and thanks for our attendees that are joining us today. Since we're a small, intimate group, maybe we can have an open dialogue, and the format that Russell and I have chosen for our seminar today is one that will be great for doing that. So we're going to keep it pretty informal and just give some kind of brief remarks using slide decks, and then hope to interact with you a lot. So let me go ahead and share my screen. All right, so just to get us all kind of oriented and on the same page, I wanted to kick us off by talking a bit about the agency that Russell and I work for. You're more than likely familiar with the National Oceanic and Atmospheric Administration, or NOAA. It's an agency that enriches life through science. So there is just a huge range of work that goes on within our agency. We have folks that are working out in the field doing exciting science that has applications to policy, to management, doing lots of operational work like weather forecasting, launching satellites, collecting information across the globe, all the way from the very depths of the seafloor to the top of the atmosphere. And so it's a really dynamic work environment. I identify as an early career researcher, and I found it to be a really rewarding career choice that I've made. I'm kind of shifting away from academia and dedicating my time to public service. And to talk a little bit more about NOAA, I love this NOAA by the numbers figure. I think it really speaks to all the different elements, or many of the different elements, that the agency contributes towards. So I had mentioned we do work launching satellites. We're involved obviously with weather forecasting. That's one of the things that when I talk to someone in the public and I say I work for NOAA, I usually start with, well, have you heard of the National Weather Service? That's a part of NOAA, because people often know what the Weather Service is before they know what NOAA is. We do things like management of fisheries, protected species. There's lots of coral research. There's a lot of coral work that goes on at the lab that I work at. There's a ton of public engagement that's going on. We'll talk a little bit about our Office of Education, which has just a number of really awesome educational opportunities to bring students in all the way from high school level through graduate level. And a lot of those opportunities allow you to have preferential hiring into federal positions with some new hiring authorities that have come aboard lately. There's marine debris research. We're doing seafloor mapping. So there's just a huge number of different directions and focal areas that scientists working with and for NOAA are contributing to. And so to get just a tiny, tiny bit into the weeds about the organizational structure of NOAA, since we do have so many different elements of work, we've broken up the agency into these 5 different what we call line offices. And just to orient you to the line offices that Russell, my fellow speaker, and I are working in are the National Ocean Service, or Russell formerly worked with the National Ocean Service. And I work within the Ocean and Atmospheric Research Branch, or OAR, or NOAA Research, which is in terms of budget, the smallest line office, but it's a line office that's really focused on doing kind of foundational hypothesis-driven science, probably that's most kind of aligned with the career path that someone, say, in academia would have. But that science is always very oriented towards the mission that our agency is focused on delivering. So a lot of the work that we do within OAR or NOAA research goes out and supports the National Ocean Service, National Marine Fisheries Service, Weather Service, et cetera. So just to talk a little bit more about my path and how I got to where I am. So I have an undergraduate degree in geology. I graduated from the College of Charleston in 2012. And some of the images that I'm showing here are the things that have really led me to fall in love with science, which, no surprise, that includes field work and getting out and getting my hands dirty in the mud as a geologist. And during my undergraduate experience, one of the most influential relationships that I built there was with my undergraduate advisor, who was somebody who was just an incredible mentor to a lot of students that were within our department. And my relationship with her is really what gave me the confidence to take the next step and to apply to attend graduate school. And I think mentors are people who really help shape your career, kind of lift you up, make you see things about yourself that you might not see without someone kind of nudging you of, hey, I think you would be really good at this, or we want to hear more from you, or we want to see you here. And so she was definitely somebody who did that for me. So mentorship has been just an incredible part of my journey, and I really try to kind of pay it forward with being a mentor to as many people as I can, and that's been a really important part of my journey. And so following my geology work at the College of Charleston, I moved just up the road to the University of South Carolina in Columbia, South Carolina, where I actually started as a master's student, a geology master's student. And after about a year and a half, or maybe a year into that program, I did my proposal, and my entire committee was like, Emily, you've got way too much that you're setting out to do for your master's, and we'd really like you to stick around for a PhD. So I switched degree tracks, and so I don't have a master's degree. I just went straight PhD. And I also changed the flavor a little bit, because a lot of the work that I had done as an undergraduate and was starting to do as a graduate student was really focused on marine geology. So looking at seafloor sediments and using them to understand the climate of the past and ocean conditions of the past, or paleoceanography. And so I completed my PhD in marine science. I got into geochemistry, which was something I certainly never thought that I would do. I didn't feel like I was a chemist, but again, once you find something that you're really passionate about, I think that the science comes naturally. And so when I was finishing my PhD, I just kind of had this overwhelming feeling that a lot of the work that I had done was focused on paleoceanography, although paleoceanographers don't really identify it that way, because I had really honed in on using sediment cores that span the last 100 years. Because the thing I really wanted to do was to reconstruct how has this phenomena of ocean acidification progressed over the last 100 years. We only have observations from ships starting in about the 1980s, but what happened before that? We know that we as humans have been pumping CO2 into the atmosphere far before 1980. And so that was the question that I set out to answer. So I had a really hyper kind of climate focused PhD project. And I felt like when I was going to conferences that I was talking with people, other fellow scientists who were well aware that climate change is an issue, and it's something that is affecting every far corner of the earth that we call home. And so I wanted to kind of change my career path away from what felt like an ivory tower of research, where I wasn't able to connect with people who were able to affect positive change as easily or readily. And so that's when I decided to apply for the Knaus Fellowship, and it's a Sea Grant hosted fellowship, which you may or may not be familiar with. I will definitely put info in the chat. The application actually just opened. But this particular fellowship brings either current graduates or recent graduates to the Washington, D.C. area to do a one-year fellowship in Washington, D.C. At just a number of different federal agencies. There's a placement process, so there's lots of different exciting opportunities you can interview for and find your best fit. And ultimately, you're placed in an office, and I was placed at NOAA. And so when I went for my Knaus interview process, one of the things that they told us was, step outside of your box, do something that isn't your area of expertise. And so I landed in NOAA's Arctic Research Program. And I am going to be honest, there was a moment in my life where I didn't realize that there weren't penguins also in the Arctic, and that penguins and polar bears were never together. That's just to share an embarrassing fact about me, to show you how little I knew about the Arctic before joining the Arctic Research Program. And I think these kind of pivots that I've taken along my career path, doing things that are completely outside of my comfort zone, have really shaped my resume in a way and helped me to build my confidence, to kind of know that like I can figure things out and I can learn new things. And with the Arctic Research Program, I ended up helping to support serving in an editorial role for this annual report that NOAA puts out every year that's called the Arctic Report Card. And as a part of that Arctic Report Card release, I also was an author of one of the chapters and got to sit on a press panel. And this is a screenshot of me giving an interview. There was a front page Washington Post story that ran about, so there was like this incredible kind of opportunity to really reach the public to talk about these massive changes that are happening in the Arctic environment. And the Knaus Fellowship kind of elevated me and gave me a platform to kind of hone this completely new set of skills that I hadn't developed as a graduate or undergraduate working in the lab. I also had the privilege of visiting Capitol Hill a couple of times. This is outside of Senior Senator Feinstein's office, where I was invited to give a briefing about a paper that I had published, actually from my Ph.D. on ocean acidification in the California current ecosystem. And my time at headquarters was extended a bit after my fellowship year. I ended up kind of transitioning into a permanent program manager role for the Arctic Research Program. And then I worked as a visiting scientist for our ocean acidification program at NOAA. And now I hold a federal position as a physical scientist working at one of our NOAA laboratories, the Atlantic Oceanographic and Meteorological Laboratory, Tacey. It is a mouthful, AOML. And I've been there for just over 2 years now. And so my journey has allowed me to go to Washington to work in a headquarters role, to see all of the incredible work that people are doing, kind of at the upper levels of management. And now I'm able to kind of get the best of both worlds and work at a federal lab where I'm able to be in the field and do science, but also making sure that I'm doing science that's highly aligned with what the public needs in terms, in my case, of climate related research. And so I have a couple of slides on the lab that I work for, which I'm just going to breeze through really quickly because I feel like I've already been talking for a long time and I was not supposed to do that. So this is the location of my lab, AOML, down in Miami, Florida. But there are a number of other labs that are affiliated with OAR or NOAA Research, the line office that I'm a part of. They're distributed across the US, as you can see here, and they have various different research focuses from global modeling, atmospheric research, severe storm science. There's a lab up in the Great Lakes region. We have kind of the sister lab to the one that I work at is PMEL, which is the Pacific Marine Environmental Lab, which focuses on largely oceanography within the Pacific region. And so, yeah, it's a great network of labs doing really cutting edge and exciting science. And it's honestly thrilling to be a part of that staff. It wasn't something I thought I would have the opportunity to do. So this is Virginia Key. This is the beautiful place that I work. So AOML is situated up here, and right across the street, we have NOAA Fisheries, the Southeast Fisheries Science Center. And across the road from us, we have the University of Miami Marine and Atmospheric Science Rosenstiel School. So we're able to kind of partner across different parts of the agency, as well as with academic partners, and we work really closely across these groups. And it's just it's a really exciting kind of vibrant research community here out on Virginia Key. So the lab that I work for, AOML, we have 3 different research divisions, and we're a pretty mixed bunch of folks. So we have lots of kind of meteorological focused weather research within our hurricane research division. So I actually work with the folks that go out on the P3 planes that fly into hurricanes. I work with the ocean chemistry and ecosystem division. So we have different groups that are monitoring carbon uptake across the ocean, coral reef health. We have a growing omics research program, an ecosystems assessment group that's focusing on kind of integrated ecosystem health. And then last but not least, we have a physical oceanography division, which has really pioneered some amazing time series and work across mainly the Atlantic region, with a lot of expertise in Atlantic meridional overturning circulation, but also, I mean, a lot of other areas, particularly not only in the Atlantic, but also in the Gulf of Mexico. And so just a very quick nod to the science that I'm doing at AOML, in case this piques any of your interest. I would love to follow up if this is something that is of interest to you. So now I was hired to start a ocean observing program at AOML, which launches Argo floats, which you can see. These are 2 scientists that are actually at this time down in the Southern Ocean, gently lowering a Argo float, which this particular piece of ocean instrumentation is about $100,000. It has a total of 6 sensors, and those 6 sensors return information using a antenna, which is up kind of near the top of the float itself. So they're transmitting these data in real time back to us in the lab. Weather forecasters are using information collected by these floats to help weather predictions. Climate modelers are using them to understand how variables are changing across the global ocean. And so we at AOML have launched a handful of these floats. This is an internationally run program, so you can see all the different countries that are contributing. Each one of the dots on this map here represents one Argo float. You can see kind of the dominant color here is green, and that's because the US contributes half of all of the Argo floats that are out in the ocean at any given time. And the target array or float array size is 4,000 floats at a given time. This is what gives us the best kind of synoptic view of what is the state of the ocean at any given time. These floats are able to make measurements all the way from the sea surface down to 2,000 meters, with some models of floats being able to go all the way down to 6,000 meters. And so I mentioned this earlier, but this is a little breakdown of the different sensors that are on the floats that I work with, which are biogeochemical Argo floats. So in addition to measuring temperature and salinity, they're also measuring oxygen, nitrate, pH, and there is a optical sensor near the bottom of the float, which is measuring chlorophyll A fluorescence and optical backscattering, which gives us a sense of how many particulates are in the water column and what their different sizes are. And that can give us a sense of primary productivity and how the biological carbon pump is functioning. So these floats are battery operated, and they're capable of collecting 250 profiles as long as there's no critical failures. And so if we're collecting a profile once every 10 days, these floats should be able to stay out and operate for up to 7 years. So in terms of when you think about carbon footprints and sending ships out to make all the measurements that these 4,000 floats are making for us every day. It's a great investment in terms of making sure that we get the observations to do the important climate science that we're doing without the fossil fuels emissions required by ships. And then last but not least, this is my final slide. I have also continued some of my paleoceanography work at AOML. This is an area of expertise that did not exist at the lab before I came in. And so this is an image taken under a microscope of these, what looks like pieces of popcorn, but these are little calcium carbonate shells of these organisms that are called foraminifera, or forams for short. And these guys live up in the surface ocean. And when they build their shells, which you're looking at here, we are able to find them in the fossil record. And we can use them to tell us about different chemical and physical conditions that existed in the ocean when they actually grew their shells. And so, yeah, all of that to say, it's been a really interesting and exciting journey so far. I'm excited to continue my career and federal research, and I'm excited to hear from Russell and have a conversation with all of you. So with that, I will give the floor to Russell.
Thanks, Emily. Let me share my screen and then I will dive in. So hopefully you can see that.
All good.
So good afternoon, everybody. I'm from the other coast. I'm out here in the far northwest reaches of the country. So what I want to do is something a little bit different, but it's really walk you through a series of stories and lessons that I learned along the way in my career as a scientist and as a leader, and that I hope that will help you as you navigate your own career. And I started out, there's the logos on the left, A&M as a graduate student, and I'll walk through that in a minute. I ended up working for the Oceanographer of the Navy, worked for NOAA for 20 plus years, and now I work out at the Washington Sea Grant Program. And along the way, I got to do a lot of amazing things. I got to go down in deep sea submersibles. I got to carry rocks to help build 800 or rebuild 800-year-old indigenous fish ponds in Hawaii. I got to swim with tiger sharks and hammerheads, and then Jerry the grouper is my new buddy there. We did a selfie on the right. So looking at this submarine on the top left, this is called the Johnson Sea Link, and imagine if you will, you're in the bubble in the front of this, and it's a big acrylic bubble, and you're dropping down through the ocean, and it's getting darker and darker and darker, and all of a sudden you can feel the cracks the sphere start to like pop and move, and with the pressure as you're going down, and it's kind of freaky. And then you could feel like a drip of water, and I remember asking the pilot, "Is that normal?" It's like, "Oh yeah, that's the drip we get all the time. Don't worry about it." Like, really? So you drop down, and as it's getting darker, you excite bioluminescent organisms, and it's like a reverse fireworks display. You know, you're going down, and all these bioluminescent organisms are flashing at you in monochrome white light. And then as you reach the bottom of the seafloor, they turn on these big lights on the side of the sub. And we, in the bottom picture here, we went down and landed on a brine pool. And what you're seeing in this image is a bed of chemosynthetic mussels with a brine pool to the top of the picture. And so if you can imagine a lake on the bottom of the ocean, taking the submarine down, landing on that, you float on it and ripples come out. So kind of a mind-blowing amount of or bit of work that I was able to do as a graduate student at A&M. I got my Ph.D. there in '92. I was a geology student, but I had advisors in oceanography and geology. So my work was interdisciplinary and fundamental science, looking at understanding fossilization potential of chemosynthetic organisms. So I was lucky enough to work on major NSF and at the time Minerals Management Service projects. I had probably more ship time as a geology student than most of the oceanography students because I had a lot of funding to go out and do this work. Was able to get a bunch of publications and national presentations along the way, and I really thought I was going to go into an academic career. Then reality set in for me as a paleoecologist. I realized, well, it's fun work, and you get to go down in submarines and go out to sea and do all this fun stuff, but there was like one job about every other year for a paleontologist. And so I figured out that I needed quickly to figure out a different option. And so I saw an ad for a Sea Grant supported marine policy fellowship. This is the Knauss Fellowship that Emily talked about. And I remember reading that going, I'm a scientist. I don't even know what this marine policy stuff is, but I needed options. So I applied and somehow magically I got it. Looking at the quality of candidates today, I don't know how I would have got it. So I got to work for the Oceanographer of the Navy's office for my fellowship. And the image down here in the bottom is the area where, or the building that I worked in Washington, D.C. It's an old historic building. It used to be an observatory. And our offices were on the left-hand side here. And it was in a cool circular compound in the middle of Washington, D.C. that was guarded by Secret Service agents. And the reason it was guarded by Secret Service agents was because the vice president lives in this compound. So it's like one of the few places in DC where you can park your car and leave the windows down and your car unlocked, and it's all good because nobody's going to get in there. So this work, though, was eye-opening for me, you know, going from doing kind of basic science to working to support senior leaders as a staff person, learning about large, incredibly complex organizations like the Navy. And I learned about the incredible passion, commitment, and technical skill of military personnel. I had no idea. I was working alongside Ph.D. oceanographers and meteorologists that were stellar scientists. And that experience totally changed my perception of the military and frankly of government service. And so while on this fellowship, I'm trying to figure out, well, okay, I still want to have this academic dream, but I realized that my skills as a paleoecologist really weren't super relevant besides academia and besides my own fairly narrow field. And so that I learned in order to be competitive, what I had to do was diversify my skills. And so I made a difficult decision, but a risk, to move away from focusing on academia to focusing on mission-focused science organizations. And as we get through my presentation, I hope you see that risk ultimately paid off. I moved to the organization, the line office that Emily works for, Oceanic and Atmospheric Research, in headquarters as a staff person supporting applied ocean science programs. And I got that job because of the network connections that I made as a Sea Grant Fellow. I got to work with some amazing leaders and learn from them. And I realized, you know, I think I could run an organization like OAR. I think I could run an organization like Sea Grant. Not anytime soon, but I clearly needed more leadership skills and experience to get there. But I had an opportunity to leave that job and go from a federal position to a soft money position at Virginia Sea Grant as the deputy director. And the reason I did that is it gave me an opportunity to learn a bunch of skills. I got to be a supervisor for the first time. I got to learn about writing grants, managing grants. I got to learn how to develop and manage competitive research programs. The bad news, I had the worst boss ever. The good news was, because he was so bad, it provided me an opportunity to run essentially the entire program. And you know, I learned a ton, basically being able to run that program. Then I got a phone call, and I was lured back into NOAA by the organization that I worked for as a staff person to lead that piece of the organization. And you know, again, this is another job because of a network connection. And I took a risk to leave a beautiful place in Charlottesville, Virginia, and move back to the big city of DC. But the risk paid off. It was an incredibly big promotion. I left NOAA as a junior staff person, came back 5 years later as a senior supervisory oceanographer. I supervised 12 people, and I doubled my salary by going away and coming back. This new job offered me a lot of lessons about the politics of science. I always, you know, was focused on, oh yeah, we're going to do good science, and it's going to be things that will be beneficial to society and move science forward. But it was really, I learned that a lot of the science is driven by political direction from the administration and Congress. And, you know, while you're doing amazing science, some of that direction is set as political agendas, which is very interesting. Also during this time, I was able to take advantage of some leadership opportunities. And one of the things that I learned in some leadership training I took that I think was a really big epiphany for me was that as a leader, my personal core values were the driver behind everything that I did. And it just taught me that no matter what, I always need to follow my core values, no matter how hard it can be. And as part of this leadership experience, I had an opportunity to run a science lab in what was called the National Centers for Coastal Ocean Science, or NCOS. And this is one of the labs within NOAA's Ocean Service. And that was one of the 5 line offices that Emily showed. And again, I got that job through a network connection. And I managed a 60-person lab that was focused on coral reef mapping and monitoring, harmful algal bloom forecasting, national contaminant monitoring, and estuarine ecology. It was the best job ever. I got to be a NOAA diver. I got to work on coral reefs. Getting paid to go scuba diving is not a bad thing. I got to do some work like looking at mapping energetics, contamination from bombs in Vieques and Puerto Rico. It's just like a cartoon bomb, but it was a real one. We got to do work looking at monitoring nutrients and predicting the hypoxic zone in the Gulf of Mexico. So this was the best job ever, but the organization that I was in wasn't healthy. And I was one of 5 lab directors. And the only time the lab directors ever got together was when we figured out how to oppose the director. It's not the way to be in an organization. I did learn some powerful lessons about what not to do as a boss from the NCOS director. I learned how not to treat people, never do it like that. I learned how not to work with leadership above you. I learned how not to work with Congress. I learned how not to develop a budget. I learned how not to develop and sell a new scientific direction to staff. So, lesson for me is you can learn a lot from the good ones and the bad ones. The director I was working with was struggling under pressure from the Ocean Service and from NOAA leadership that wanted to eliminate this whole network of labs. And I ended up taking a risk from my lab director position to be the deputy director, working for a man I didn't really respect because I believed in the people and the capabilities of the organization. And it was hard to do that, but I gave it my all. And about a year or so later, I went on vacation. And I recall sitting in a pool in the Virgin Islands, might have had a glass of rum in my hand, thinking about how to extricate myself from this job. And I went back to my office in DC, and I was like, I'm going to go back to running my lab. And about 2 days later, I got a call from the head of the Ocean Service, who never calls people at that level in the organization, asking me if I wanted to be the acting NCOS director. They were going to move that director to a different position. And he said, "You want to think about it?" And I said, "Nope." And I immediately did it. And it was an incredible risk, again, to go from where I thought I wanted to be to leading a larger organization. So I was an acting director, meaning that I didn't have the job formally, but I was asked to do all of the job responsibilities. I did this for a mere 37 months, but I did it like I was the guy. It was an on-the-job audition. And so I ended up formulating the future scientific and organizational direction for NCOS. I gained support from the Ocean Service and NOAA leadership. I gained support from Congress. I gained support from the Office of Management and Budget, which is the White House. And I also had a stint of serving as the deputy of the entire National Ocean Service. So in this job at NCOS, I managed 180 people. I had labs in 4 states. On the left here are some of the labs. This is the top one is our lab in Alaska. Middle one is a lab in Beaufort, North Carolina. And the bottom one is 2 labs that we had in Charleston, South Carolina. So, it was incredible. I also was asked to be the Ocean Service deputy for another 4 months. And this was during the middle of the Deepwater Horizon response. That was an all hands on deck response for NOAA. I realized at the time that I could be the deputy of an organization like the Ocean Service, but I didn't want to. It was just too hard. It was painful. So I ultimately was able to compete for the NCOS director position. And this was a senior executive position. I got it in November. And in January, I was offered the position of the NOS deputy director position. And again, another huge risk. I knew that I didn't want to do it a few months ago, and I immediately said yes. I guess I just don't learn. So I ended up being the NOS deputy director for about 8 months, and then the director left to go work for a nonprofit. And this was another on-the-job audition for the director position. And then ultimately, I got the position of the head of the Ocean Service, formally transferred into that by the head of NOAA. This was the hardest job ever. It felt like it was 24/7. It was also the most rewarding job ever. I had a national scope and influence. I supervised an admiral. The picture on the right shows me out by one of the NOAA ships. I'm the guy with the suit as opposed to the guys in the military uniforms. My boss next to me was a 3-star admiral, and the guy that you can't quite see because of my little windows here was an admiral that I supervised. I got to go diving with Fabian Cousteau on the Aquarius in the National Marine Sanctuary in the Florida Keys. He was trying to spend 31 days underwater to beat his grandfather, Jacques Cousteau, who did it for 30. So the sanctuaries program were part of the Ocean Service. We also did a lot of work looking at predicting tides and currents and allowing and facilitating commerce, like letting this big ship move through essentially at steam under a bridge with minimal clearance. The ships on the bottom right were a couple of the NOS. They're owned by another part of NOAA. It's a little complicated, but they were kind of run by the Ocean Service, and they were getting ready to go do hydrographic mapping in the Arctic. So it was an amazing job. I worked for a former astronaut who was frankly the best leader ever that I could have worked with. Oops. What did I do? There it goes. Wait. Okay. So I did a lot of hard things in that job. I had 60-hour work weeks. I had frequent travel. I had a ton of public speaking. My life was scripted and tied to my calendar. So here I am yapping away at a podium, did a lot of that in DC. I spent a lot of time on Capitol Hill, educating, we couldn't really call it lobbying, but educating members of Congress and their staffs and trying to convince them to support our work. So again, going back to the science political interface in terms of being able to get funding for science. The image on the top right, image on the top right is the fish pond that I was shown moving rocks at in the first picture. And so this is a pond in Kaneohe Bay on Oahu in Hawaii. And I helped to get over the finish line a National Estuarine Research Reserve, a marine protected area in Hawaii that encompassed the mountains at the top, the taro fields here, an 800-year-old fish pond, and the coral reefs offshore. I was also able to have a pivotal role in creating the Papahanaumokuakea Marine National Monument, shown here and outlined. At the time, it was the largest marine protected area on the planet. And one of the accomplishments that I'm also really proud of was working with Cuba when we normalized those relationships in developing the first modern hydrographic map done jointly between the US and Cuba that basically was a seamless connection between the two countries. I also learned in this job that I had to do the right thing no matter how hard. I had to sort out some incredibly stressful personnel issues with a nationally renowned senior executive. So think attorneys, think non-disclosure agreements, that's all I'm gonna say. I was asked to be the final decision authority on a high-profile scientific integrity issue. But going back to the core values that I mentioned, that's what got me through this. I wanted to always try to do the right thing. So I felt like it was time to go. I felt like I was burning out working these long hours, and I had some personal things that happened in my world. So I wanted to find a different challenge. I wanted to continue working in a science-based organization but at a smaller scale. So the job at Washington Sea Grant opened up. It's in a beautiful part of the world. I love the mountains. I love the ocean. So it was a great opportunity. It was a huge risk. It was a huge risk to leave DC, to leave that high profile position that I was in. It was also the first position, I think, maybe second position in my entire career that I applied for without using a network connection. The thing is, they knew who I was because I had a national reputation. So they were excited to have me come on board there. The reward was I joined an incredibly cohesive team. I have a supportive boss. I work in an amazing and beautiful part of the country. And I regained some work-life balance. So some of the things we do are we're training commercial fishermen to stay alive. We're doing work with invasive crabs. We're doing work with shellfish and kelp aquaculture. We get to support students doing work in the field. And my work-life balance, I got to get up Mount Rainier this summer as an old 62-year-old guy. So, I had a lot of fun along the way. A few quick lessons, and then I'll stop and open it up. So in terms of leadership, I would say embrace being a leader. You don't have to be the most super technical superstar to be a leader of organizations. Be true to your core values. Treat people fairly. I learned some painful lessons as supervisors. No matter what, treat everybody fairly. Celebrate the team. Celebrate and support a diverse, inclusive team. Create a safe space. Do what you do as a leader of the team and the organization, but not for your ego. And learn from all leaders. Learn from the good ones. Learn from the bad ones. In terms of careers aren't linear pathways. They will take unexpected turns. Be willing to take risks. I try to talk about a bunch of those risks I took in my career. Virtually all of them paid off. If you get a position where you're asked to do the work, but not given the job formally, do it like you're the one. Go full out. Build and cultivate networks. That's, my employment wasn't about people getting a job for me. It was about me being known in the community and building those relationships. And overall, have fun. Have a sense of humor. I actually was told one time by a boss that I make too many jokes in meetings and I need to be more serious. And I told him it wasn't going to happen. So anyway, just a quick whirlwind through a career of somebody that went through A&M and was able to make that transition to a federal scientist and federal leader. Tacey, let me pass it back to you.
Awesome. Thank you very much for both of you giving your sort of background and your story of how you got into science. I think I saw a question that came already in the Q&A for Emily, and I saw that you said you were going to answer it. So we can sort of start with that one if you want. For anybody, I don't even know if anyone can see it. The question was, how much freedom is there in research at NOAA, and or who determines the specific projects that are conducted? So Emily, you want to answer that, or even Russell, if you want to jump in, that's fine too.
Go,
Sure.
Emily, I can give you my perspective too.
Yeah. Sure. Yeah, Samantha, thanks so much for that question. And I don't use Zoom very often, so I'm sorry that I clicked a bunch of buttons and said I was going to answer it. So yeah, I would say, and I did type this in the response, but I'm not sure if everyone can see it. Generally in my world of kind of science to support our understanding of how climate change is affecting our oceans, it's a pretty wide open research space. So for me, there really hasn't been bounds that have prevented me from asking the research questions that get me excited. But that being said, and Russell kind of mentioned this when he was transitioning from his academic work, there are some bounds to that. Like if you're gonna study, like I can't even think of examples whenever I try to do this, because I'm like, no, I think NOAA could do that. Essentially, you have to really map back any of the science that you're doing to be related to the mission of the agency. But the mission of this agency is awesome. Like, we're doing science to understand climate impacts, to track fisheries, to predict weather, to understand extreme storms. So there is a pretty wide range. But that being said, like, for example, when I accepted this job to work at AOML, I was interviewing for a job to manage and start a research program using a technology I had never used before. And so being able to pivot and kind of recreate yourself and being okay with the science, the essence of the science question is something that I'm interested in, but this tool or approach is something I haven't used, I think has been really beneficial to me in my career. It's definitely scary and gives me like mad imposter syndrome every time I make one of these pivots, but it's been rewarding ultimately to me. What do you think, Russell?
Yeah, I actually found, running a lab and managing scientists as well as doing hands-on science in NOAA, that I felt like there was a lot of flexibility. And generally it would be, here's a problem that you need to solve. And then it was like, what's the best way to solve it? What's the techniques you need to do? What's the research you need to do? What's the monitoring that will help you answer that question? And I found that there was a ton of flexibility. In the labs that I managed were smaller than AOML where you worked, but we went after a lot of money through competitive grants. We'd be, let's say, approached by somebody like BOEM saying, "Hey, can you give us, the idea of habitat suitability, do some modeling related work to help us make decisions about offshore renewable energy?" And so, pretty big question. They were looking for a product. You could figure out what you needed to do that modeling to produce those products. So just one example, but I think there's a lot of flexibility. Surprisingly, you're thinking you'll be boxed into like you must do this thing as a federal scientist, but I think it's pretty wide open.
I think that's awesome. I feel like that's probably a big question people think of when they're sort of deciding between an academic track versus a research scientist versus something else. I feel like that was a really good question. We had some questions submitted when people registered as well, so we can do those. And if anybody who's listening has a question and wants to ask it, they're welcome to raise their hand. If you don't feel like talking, which is totally fine, if you type it in the chat, one of us will read it and answer it live, and that works as well. So we had a question submitted by David Woods, who's a student at the University of Houston, and I don't think he's here, but he was wondering whether or not you feel, now that you've had experience maybe in the government or working in some sort of capacity for policy related avenues, that your expertise and your background is actually listened to and respected, and it comes across as such.
I can try first if you want. So, yeah. Having a 20-year career in NOAA and now coming back to work in a university environment at Washington Sea Grant, my experience is unique. And, because I've had some high-level leadership experiences as well as a lot of science-based experience, my boss leans on me to help her solve some of the leadership challenges within the college. And she's reaching out to me because I have that experience that's not the experience that almost everybody else that she's working with. So, I think in that perspective, it's well respected, having that knowledge, having that background. And, working as I did in DC and now working at the state level, I find that my skills transfer incredibly well to working with the state legislature, to working with NGOs, to working with other state and federal partners in our region.
Yeah, that's a interesting question. I think I hesitated a tad because I don't necessarily feel that my voice is more or less respected. I think I'm struggling with that word because of the position that I hold. But I think that this experience, the opportunity of working at NOAA has provided me platforms and doors to communicate with people that I think in an academic setting, particularly like in an early career stage, like being able to stand up at a meeting at the White House and talk about our research objectives for ocean acidification, or going to Capitol Hill and talking with staffers about Arctic science and the need for kind of the climate work has to go on despite the administration recognizing or not recognizing climate change. I came in and was started my fellowship just I think a mere 2 weeks after Donald Trump was inaugurated into office. And so I spent a lot of time working under the Trump administration in my initial years. So yeah, I think it opens different opportunities to be heard by different groups. And I also think that there's just such like a fundamental different way that, in my limited academic experience, that people communicate. So in this government sphere, I think I've learned a lot about how to kind of pitch the message, how to make sure you're really like keying into what the audience is interested in and being responsive and just like communicating and tailoring things in a different way, because it's just required. Like when you're working at this higher level, which I didn't reach the heights that Russell did in his career, but working at headquarters, you get these turnaround requests really quickly where you have taskers and you have to write a paragraph about what feels like the biggest issue in the whole wide world to you. And so it really helps to like hone what's important and how you communicate it. And I think that helps get the message across a bit more succinctly and in a way that is more impactful.
I'm going to pile on a little bit. I think the skills of being able to communicate complex science and policy issues in a way where somebody who's not a scientist can get it is an incredible skill. And it's one that I certainly learned to know, and it sounds like you did as well. And, you know, when you're talking to a member of Congress or a congressional staff, they want to know, they want to understand. They don't want to see how brilliant you are. They want to understand, what is this ocean acidification stuff? What does it mean? You know, explain that where I can get it. Because, you know, so having those skills to really communicate effectively, it's going to pay off, no matter if you're a federal scientist or at the state level or even in academia.
Awesome. Yeah, that's a pretty loaded question for sure right there to start with. I think you guys did a great job. Our next question that was submitted is from Elliot, and I'm going to butcher this last name, but Lagu, I'm not quite sure. Also from University of Houston, who is not here either. But their question was whether or not you feel, after working in the government, that there are currently enough scientists within the executive or legislative branch involved to cover a breadth of knowledge that makes sort of that level of expertise possible, or whether there are sort of gaps maybe in some of these different areas. Big, also a question.
Yeah, I can hop in quickly because I have an example that comes to mind immediately. So especially with the transition to the new administration, there's been just like a huge renewed interest in climate science. And almost right off the bat, NOAA felt really inundated with all the different requests and things that we were being asked to do in a good way. But there is a limited capacity to what, you know, we're set up to do. And so one particular request that I see that there is currently a gap in terms of expertise is we've been asked we formulated a task team that's focused on marine carbon dioxide removal. And so in terms of like, we at NOAA have to figure out where do we fit in this space, what legally makes sense for us to do, and who within our federal workforce has this expertise. And frankly, to be honest with you, right now, nobody. And so we have some people who are maybe carbon scientists that are like morphing into focusing on marine carbon dioxide removal, but this is a huge question and one that's coming at us super fast. And so we're kind of scrambling to put together what is NOAA's position on marine carbon dioxide removal. Where do we see ourselves fitting in? It's probably more in like a foundational understanding, monitoring kind of capacity. But that to me is like a wide open space of kind of a field of research where, in terms of the task force that I am a part of, and I am not a marine carbon dioxide removal expert, there's no one there that like has done that or thinks about it full time. So that is one such example in my little world, and I'm sure that there's lots of other examples. But that being said, in those kinds of instances, the way that the agency is set up is that we have these really awesome collaborative agreements with consortiums of universities. And so there are lots of different mechanisms for us to reach outside of the small pool of NOAA researchers, or relative small pool of NOAA researchers, to tap into expertise that's in the academic space, in the kind of private space too. So we lean on those partnerships, I think, when those cases arise. But yeah, that's just one example.
Yeah, let me follow up a little bit. I would say the short answer is no. There's not enough scientists. And one of the challenges in the federal government, actually, I think in any large organization, is just simply an inability to hire. And so what NOAA does that I think is very creative is they engage contract companies that bring contractors on board, and those contractors work for a company, but they'll be working hand in hand, maybe in the same lab, in the same office space as a NOAA employee, pretty much indistinguishable in terms of the kinds of work. The cooperative institutes, so there's institutes associated with major universities, such as University of Miami. University of Washington has an institute with the Pacific Marine Environmental Lab, the NOAA lab here. So they're basically having academic scientists working in those NOAA labs. And NOAA also funds a variety of what they call partners. So Sea Grant programs, for example, there's 34 of us around the country. Pam runs one here in Texas, they're in Texas, I run one here. But we do a lot of work hand in hand with NOAA. NOAA also funds coastal zone programs and estuarine research reserves, et cetera. So there's a lot of different avenues to have like a matrix. It's not all federal scientists, but it's people that, what I find is amazing, it's people that truly care. They care about the natural resources, they care about sustainability, they care about the planet, they care about things like marine carbon dioxide removal and how do we figure out how to deal with that. So it's an interesting kind of mix of different partners and relationships that help conduct the science that NOAA, other agencies do.
Yeah, I think those are really good points. It's a great answer to a question I probably wouldn't have really considered. I totally get that. And I think this question sort of leads into sort of some of that work, right, where you have such a wide breadth of scientists, and a lot of these teams, especially in some of the larger agencies like NOAA, are quite big. Even the Sea Grant teams are probably on the larger side in terms of, working and managing. So what do you guys feel like are some of the drawbacks or benefits of either managing or working in such broad categorical teams and groups across a large agency like NOAA or Sea Grant?
It's not as large as you think, it's just like anything else, any other group where you build relationships and you build partnerships and you build connections and you build a network. Working in NOAA as a scientist, you start to realize who else is doing similar work or complementary work that you can partner with, you can write proposals with, et cetera. So it's interesting, like the ocean science community, even outside of NOAA, isn't as big as you think. As y'all continue in your careers, you'll be running into the same people over and over and over and building those relationships. I may not have answered the question, but I think gives you a sense of it's actually a smaller world than you think it might be.
Yeah, I would tend to agree with that. Just in general, like science feels like it is a quite a small world. That being said, so AOML is a lab of 200, and we, as I mentioned earlier, have a lot of different diverse research questions that are happening at the lab. And I actually find it really nice that I'm co-located with the Hurricane Research Division, because that allows for me to walk down the hall and ask about, hey, if I rapid cycle my BGC Argo floats in the Gulf of Mexico where Hurricane Ian is passing through, would that be of interest to you? And so I think that there's actually like a decent amount of collaboration that's set up across like these interdisciplinary bounds, which I don't think is necessarily something that I would experience in academia, and even in the broader agency space outside of NOAA. When I was working at headquarters, one of the things I was spending a lot of my time doing was interagency coordination, and there's bodies and requirements for different agencies and representatives to come together and coordinate the science that we're doing. There's cool opportunities for agencies to come together to write competitive calls for research funding. So there are a lot of mechanisms for us to come together in ways that, yeah, I think is kind of unparalleled in maybe the academic space. I'm trying to think of a drawback because I mean, there are definitely drawbacks, but in terms of, yeah, this question, I'm coming up a bit stumped.
I mean, it's not a bad thing to not have any drawbacks, I suppose. Do you have anything to add, Russell? You look like you're on the cusp.
Yeah, I'm just sort of mulling this over. Like, I mean, there is a competitive streak. I mean, the interagency partnerships are really important because, you know, an agency like Interior, for example, has different skills than NOAA does. And so it's great to partner with them. But there's also a competition that you have to manage. But I think, again, if you can build those relationships, you can work through that competitive craziness that people get.
Between agencies or between people?
Between all of the above. It's, yeah, there's
well,
been a
no,
long standing. I know, but so there's venues though that, like, I was able to sit in on meetings convened by the White House to bring Interior together and the Department of Defense, primarily Navy, together, and NOAA and NGO communities to sit down and talk about a particular topic and to help scope out, like, what's that direction we need to go? Who can invest? In other words, who could put, let's say, money out in competitive grants that we could then stimulate the academic community to respond to? So it's kind of cool because there's those interagency fora and the White House sponsored fora that help to set directions and fund science. So things like marine carbon dioxide removal, yeah, NOAA may not have those capabilities, but I bet they're starting to figure out how to do it. And I also bet that they're going to be putting money out in competitive grants to get some of that work done. So it's kind of cool to see the sort of what NOAA may be thinking about now. In 4 or 5 years, there's funding streams and there's you know, bodies of work being developed on that.
I did think of a drawback. Russell inspired me. So this may be even deviating from the original question, but I think something that can be a bit frustrating in working in the government is that the wheels churn slowly. So when there are kind of, oftentimes, not always, but when there are these kind of emergent issues or topics, it can be hard for us to get proper staff, hiring experts, dedicated funding that's sustained, that can provide kind of meaningful direction to answer big questions. But that being said, like, some of these partnership relationships that Russell and I have been describing here are really helpful in allowing us to be a bit more agile in that way. But when we want to make big changes, maybe that's a good thing. It takes like years to really see programs change and budgets to identify these new lines of funding and program. And so that can be a little frustrating at times.
That's fair. I like those all feel like very valid sort of drawbacks, benefits. It's a nice sort of play between the two.
Yep.
Okay, so I have another sort of question from somebody else that had asked previously or before. And I think this is something that most people who are maybe interested in foraying into the field of science policy or learning about it, right, is that idea that if you sort of leave this world of academic and research, it's very hard to maybe go back and you're essentially giving up potential options or things like that. Was there ever a point that you felt like maybe you regretted going down the policy avenue, or that you felt like you couldn't do something because you had left sort of this academic, specific academia sphere or track?
Yeah, I know in my first couple weeks of starting the Knaus Fellowship when I was at headquarters, I remember asking my boss at the time if I could have a microscope at my desk. And he was like, "You want a what? Like, there's no microscopes in this building. Like, there's no lab spaces in this building. This is not a place where outside of maybe like modelers or weather forecasts that there's like really science happening. Like we are facilitating science here." And so it was definitely shocking, which I think is an important part of the experience because we want to move away from what we're comfortable with and build new skills and get outside of our comfort zone. And that's definitely what the fellowship was. And you learn and you grow a lot when you're kind of in these nerve-wracking, uncomfortable spaces. I definitely wanted to give it a couple of years, but there was this like kind of pull that I felt in my gut of I'm enjoying what I'm doing. This is super important work, but it's not like the thing that I envision myself doing. And it's not, I feel like there's so much that I can give that I'm not giving in this particular capacity. And so I was able to align myself with doing climate assessments. So I worked on the State of the Climate Report, the Arctic Report Card, and was helping with kind of strategic kind of research writing and things like that. So I was still getting my name out there and building my CV and writing papers from my PhD on the side. And when I published my last chapter, I was kind of at a crossroads. And that's when this position with AOML came out, and I applied, not because I would say networking played a role, not in terms of they were like, "Oh, Emily, you should apply for this job. You would be perfect," because I'd never done the thing that I am now responsible for doing. But once my name was in the list of these are your referred candidates for this position, the folks that were interviewing me knew of me and knew my name and were able to contact people at headquarters I had worked with to get this scoop on, can Emily figure this out? And the answer was yes, because I'd figured a lot of other things out at headquarters. So yeah, you can demonstrate skills and kind of grow in a different way. Like I didn't do a postdoc after my PhD. I did the fellowship and then went kind of straight into this position. So there are times where I'm like, oh, I didn't get a master's. I didn't do a postdoc. I feel like I'm underqualified for this research position. But the people that hired me reassure me every time that, Emily, you did a postdoc in NOAA and you know so much more about how this agency works than other people that work in this lab. And I think respecting that is a huge benefit, at least for me, being able to stay within NOAA was helpful. But yeah, I definitely had people saying to me when I accepted the fellowship or throughout my journey, saying things like, "Oh, you left science and you're not a scientist anymore." And it was a bit of an identity crisis. And I think that's just like kind of the BS thing to say to anyone in general, like you don't leave science. But I think it's a less traveled path to go into policy and then come back into research, specifically to be able to come into a research position at NOAA. I feel like I really lucked out, but people definitely do it. And there are people that go back and get their PhD or do a postdoc or kind of go back and they have a whole new set of skills. So it's not impossible, but I think that you have to time it right. You can't, I mean, realistically, you can't stay in a program management position for a decade and then expect to get a professor position or a lab position. So there's a bit of timing, but it's definitely not impossible. And I think that there are real benefits that polish you and kind of hone your skills in a completely different way.
So my answer to the question is going to be different than that. You know, if you leave academia, can you go back? And I remember when I was going on to a Knaus fellowship and I talked to one of my graduate student colleagues at A&M and he's like, why do you want to do that when you can do this incredible science? And I get to DC and I see my eyes opened up by the incredible science done for the mission that the Navy's doing, you know, doing high-end oceanographic modeling incredible acoustics work. And I'm like, I don't think we'd be doing this in academia. And so, my answer to the question, if you leave it, can you go back? And my answer would be, I never wanted to, because I got so many rich experiences. I got so many different positions and challenges along the way that, after I made that decision and started getting, running a lab, running multiple labs, I never looked back. And when I came to the University of Washington, they said, well, you can come back as a Sea Grant director and be staff, or you can be a professor. And I said, well, what's the difference? And they said, well, you have to jump through a few more hoops to be a professor, but it's really all about status. And I told my boss, if I wanted status, I wouldn't have come back, wouldn't have come here. And it kind of shocked the dean. But, for me, it was about making a difference, as opposed to, whether I'm working in a university as a scientist or working as a federal scientist. And I think I made a bigger difference than I would have been able to make if I had stayed, even if I ran a pretty amazing lab at 12 students and postdocs and all that, marshaling a force of 1,800 people as I did in NOS, I never would have pulled that off in academia.
Yeah, I think those are definitely like the two sides of the coin, right? I feel like that you hear about, but it's nice to get both answers, because I think that is something that's still a little bit maybe of a concern for some people, sort of trying that new thing or branching out from research. And I think it's really important to hear the different perspectives and why or why not.
So Emily talked about getting out of your comfort zone. I had a conversation with my boss, Dr. Kathy Sullivan, who's that shuttle astronaut that I referenced. And I said, yeah, I got out of my comfort zone about 3 times last month. And she looked at me and said, that's all? So, I'd urge all of you to think about getting out of your comfort zone and see where it goes.
I think you get to learn a lot of new stuff. I mean, I feel like oceanography is one of those unique degrees as well, that a lot of people who start a degree in ocean science, often it's already out of your comfort zone, because it's not generally like as commonly studied as an undergraduate, or if you haven't done it. Right. So I think, you're talking to the type of people that are maybe a little bit more willing to jump out of the norm. But on the same sort of like lines, I guess. So you guys have both mentioned doing the fellowship, and you'll notice for people that are in this webinar, right, many of our speakers have mentioned the same fellowship or a similar fellowship. It's a very big common theme for a lot of scientists moving out of this degree. And we will do a fun sort of webinar on examples of that on December 6th for anybody who wants to hear more about these fellowship opportunities. But if you could choose or go back and sort of tell your previous self, or get a chance to do it over, aside from the fellowship, is there something you'd wish you'd done or participated in, maybe as a student, undergraduate or graduate, or even just after graduation, that might have helped you maybe lose some of the imposter syndrome, or branch out, or do something a little bit different that would have helped career-wise, maybe where you are now or where you wanted to be at the time?
It's a really good question, Tacey. Your mention of imposter syndrome kind of clicked me into my answer. I feel like something that I've really grown into in the last several years is really owning that imposter syndrome, talking about it, and trying to make just kind of an inclusive and like safe space in all of the places that I work and operate, and trying to just be like more open and honest and having those conversations, because I think it really like changes the environment for everyone. When I started working at AOML, it was during COVID, and I partially did this because I definitely was benefiting from a bit of extra social networking, but I created a group within my division, Women of OCD, and we've continued to meet over the last almost 2 years now, every month, and we talk about all sorts of different topics that just make all of us feel a lot more comfortable and a lot more open and a lot more lot less alone in some of the things that we're experiencing. And I think as an undergrad, and definitely in that academic and even in a NOAA setting, I mean, in any professional setting, it's probably the case that I think I was always really, really scared to raise my hand, to speak up, to be the one that didn't know the answer, or to say, you know, I feel like I don't belong here, because often other people feel that way too. And so I don't know if that's like really an appropriate answer to your question, but that's the thing that came to mind. Is I wish that I was a little bit more comfortable to help kind of break down some of the toxic cultures that exist in academia when I was in undergrad. And I've been working hard to do that in my career lately.
So I can think of a couple things. I mean, for me, I think if I had more formal science communication training, I think that would have immediately paid off, because I had to figure it out along the way. I think the other one is, you know, kind of going from working on my PhD and basically feeling like I owned the entire project. I had to run it, I had to manage it, I had to do all the work. And then, you know, going to NOAA, and it's like, now there's a team of 4 people and you're working on this project together. And so, you know, if I had and maybe it's different now, because that was, you know, back in the 80s and 90s, like back when, you know, people drove, you know, Model Ts and stuff like that. So, you know, I think, you know, doing things in a team setting more would have really prepared me for, you know, jumping into the Navy, jumping into NOAA like I did. And in terms of the imposter syndrome, I got it. I have it every day. I've had it my whole career. I learned that I may not be the smartest person in the room, but I'm going to be the most prepared. So walking into conversations and having done my homework, done my reading, done my research, being ready to participate and lead those conversations, you know, I feel like I'm not near as smart as half the people there or more. But I always was able to contribute and make a difference because I was ready and I was engaged. I went to a meeting with the head of OAR one time, and he was meeting a Danish scientist, and I was asked to join the meeting. I had no clue, so I spent a bunch of hours trying to read up about this guy and the science that they were working on. I got in with the head of OAR and the scientist, and it was me and the Danish scientist carrying the conversation because the head of OAR didn't do his homework. You know, much smarter guy, better position, but, you know, be prepared.
I think those are both very equally great answers. I think it's just, you know, that's that hard thing. I feel like as a scientist, because there's always so much, it's always changing, it's always improving. You just always feel like you're not prepared. And I think that's, you know, learning to sort of get better or accept that, I guess, embrace it is definitely a good sort of life lesson, or find ways around it. Being prepared is always a good way to sort of back yourself up. I think we're pretty much almost out of time, but I guess maybe we have about maybe 5 to 10 minutes. If anybody has any questions, I haven't seen any yet, and they want to sort of raise their hand and jump in, feel free. But otherwise, maybe, I know you both have shared quite a few stories and things like that, but you have maybe like a favorite experience or story, or it doesn't have to be science related, something from working at NOAA or at Sea Grant that, you know, that's just like your hallmark of, you're like, I love this job, or I love what I do kind of thing.
I think something that I haven't talked too much about today, and something that I really love about the position I have being a NOAA scientist, is the ability, I wasn't planning on saying this, but I feel like I truly, and Russell, I'm sorry, I completely can imagine that being the head of NOS doesn't come with work-life balance, but I feel like generally for a federal, in my experience, I have had the ability to have excellent work-life balance. And I think it's the culture around work-life balance in my world versus what I see in academic colleagues' world is really different. I have weekends, I have nights, I'm not expected to work beyond 40 hours. And if I do, I'm compensated. And I feel like I'm a lot more comfortable with kind of this particular setup than what I saw in my academic experience. And so that's great. But one other element is that not only am I able to work in the lab and go into the field and do cool research, but I'm also like kind of on a short list of people who get tapped when there are these really awesome requests coming from the White House or Congress asking for what's the latest in this area of science, what's the direction that we should be moving in. Working on the National Climate Assessment, working on the State of the Climate Report. Those are things that I particularly get a lot of joy from doing. There are many academic partners that participate in that as well, but that is just kind of a valued element for being a NOAA scientist, is really being encouraged to participate in those kind of assessments and reports. And I get a lot out of doing that and really have enjoyed that being a big part of the work that I've done at NOAA so far.
I think one of the things that I'm the most proud of in NOAA, I actually shared it with you briefly, and that's helping to ensure some major conservation successes. So being able to help make the case for developing large marine protected areas that can protect the ecology of a swath of the planet. For me, that's something I'm just so proud of being able to do that and playing a role and feeling like I helped to create and share something for future generations. And that sounds kind of corny, but it's like, it's a place that hopefully won't be touched. And the other piece that I think of is that I've really tried to give back along the way. I've tried to take care of my folks. I've tried to protect them from political appointees. I've tried to mentor Canals Fellows, having been a Canals Fellow. I try to do that a lot, and I will continue to do that. And so for me, like anything I can do that helps the future, the next generation, happy to do it. So I'm happy to answer questions later. I'll share my email with everybody. So feel free to reach out.
I can definitely sort of sympathize is the wrong word, but connect to both of those answers. The work-life balance for me is definitely a reason why. So I'm sort of drawn maybe to this slight change in path, but still be able to be part of the science. And I think that, being part of such an important field is probably why most of us started here in the first place. So I think those are both very realistic answers. I feel like we have a few more minutes, but I haven't really seen any other questions. I don't have any more questions for you guys. If there's anything you want to add sort of last minute, feel free. For anybody that's still in the webinar, we have another one in 2 weeks that's doing a little bit more science communication, like Russell sort of alluded to. Get some background on doing a one-pager and some infographics, terms I had never heard before this year. So I feel like, infographics I have. But, it's a nice sort of chance to maybe branch out a little bit from what you already know. And then we will do one on some of these other fellowships like the Canals as well as the Gulf Fellowship on December 6th for anybody interested in maybe taking a chance and branching out. But if you guys have anything last words to say, feel free. Otherwise, I think we are pretty much good to go.
My last words are, don't be afraid to take risks and have fun.
Love it.
Awesome.
Yeah, thank you so much for the invitation, Tacey, and I want to recognize you for the awesome work you've put into organizing this whole thing. It's been a pleasure getting to work with you on something else again. And Russell, to serve alongside you on this panel, it's been really wonderful too.
It has been fun. See, we're having fun.
Thank you very much. I really appreciate both of your guys' contribution and your help. And you've just been really great for my experience. And then I hopefully for some of these other people as well can get a chance to see your wonderful backgrounds and paths. Well, thank you very much for everybody for attending. And I think that is all that we have for today. And I will hopefully see many of you in 2 weeks.
All right. Bye,
Thanks, everybody. Bye.